Hey everybody, this is the Banana Leaf development team, and today we'll be presenting our liver segmentation web app project. Currently, in the treatment of liver cancer, a radiologist must obtain an MRI or CT scan of a patient's liver and manually segment the images based on its anatomical parts. The current process is time-consuming and laborious. So our solution was to develop a web-based liver segmentation app that provides all the standard features of a medical image viewer with the ability to interact with DICOM series and segmentation masks, and is capable of producing segmentation masks using our deep learning model.
So for our deep learning model, we used the unit architecture. The dataset was provided by Dr. Roger Goldman, and our model was trained on 153 scans with a total of 9,288 images. To calculate the performance of the model, we used the mean IOU metric, and essentially this is a measure of overlap between our predicted and the actual mask. And across 20 scans with a total of 1,042 images, our best model was able to correctly predict the segmentation with a score of 64.1%. And now Katarina and Mitch will be demonstrating our web application.
So upon loading up our website, you'll be met with the study search bar. You can search by any of the parameters in this header. I want to use kit 0. And next you will come across the series search bar. If you had more than one series to load, you could again search by these parameters.
When designing our interface, our client sent us MIM and Aquarius as inspiration. We also found Slicer and OHIF Viewer as our own inspiration. We extracted common base features from these programs and implemented them to provide a familiar DICOM experience for our users while still on the web.
While Mitchell's been talking, I just showed you the zoom, pan, and contrast tools. Now this last one is the stack scroll, which will show you how we can scroll through all the instances. Next is the brush. So here I can draw in one segment, and I can easily switch to another segment. If I don't like what I've done, I can also undo and redo. And of course, we have a machine learning model which will predict the segmentation masks. It'll take, well, it's loaded now, so we'll show you the output of that. You can see here, much more intense. And these are editable, so I can change this. And if I want to save this improved segmentation mask, I can save it to our data store here, or I can download it directly to our computer here. The user is also able to upload a new DICOM file, or DICOM series. It'll then be directly uploaded to our data set. If the user decides they don't want this series on the data set anymore, they can also delete it. And of course, we can return back to our series search and our study search.